So my fx was x cube minus 3x plus 1. My f dash x. My f dash x is the slope function. I'll repeat. My f dash x is my slope function. What does my slope function do? The slope function gives me the slope of the original function. And if I put this slope function to be 0, I have 2 points, x is equal to plus 1 and minus 1. So what I suspect, actually I don't suspect, I know that at x is equal to plus 1 and at x is equal to minus 1, the slope, the function will have 0 slope. Are we clear?
Yeah.
Now my job is to understand which of these would be local maxima and which would be local minima. Are we clear?
Yeah.
Now let us try to understand that. Now so these points where the slope is 0, that this is what they are saying. Gradient is a 0, is called a stationary point or turning point. So this is where the graph will turn, but whether it will be local maxima or it will be local minima, that is what we need to understand. Are we clear till here?
Yeah.
Yeah. Okay. So my slope function is 3 x square minus 1. I can write x square minus 1 as x plus 1 into x minus 1. Are we clear till here?
Yeah.
Okay. Now look carefully, and if you don't understand, please ask as many questions as you can. So I need to trace this function. This is my slope function. Now what I know is that the slope function, this function at x is equal to minus 1, this, if I put x is equal to minus 1 here, the slope function would be 0. That is what I have understood. The value is 0. Now let me look at the left side of this point, the left side of this point. So let me take any random point like minus 2. When I take a point like minus 2, which is on the left side of minus 1, and I put here, so this would be minus 2 plus 1, this would be minus, and minus 2 minus 1, this would be positive. Is it making sense?
Yeah.
So minus plus minus into plus is minus. So here my f dash is negative. Am I making sense?
Yeah.
Left of minus 1, the slope would be negative. Are we clear?
Yeah.
Okay. Now let us look at right of minus 1. So I'll take a point somewhere here. Let me take 0. So if I put 0 here, 1 into minus 1, again it is negative. Are we clear?
Yeah.
Are we clear why it is negative?
Yeah.
So minus 2, no, there's a mistake I've done. 1 second. If I put negative here, minus 2 here, so this is minus 2. Okay, so if I take a point which is on the left of minus 1, so let me take minus 2 here. So when I take minus 2 here, so this would be minus 2 plus 1, this would be minus 1, and minus 2 minus 1 would be minus 3. So minus into minus is plus. So actually my slope function is positive on the left side of minus 1. Am I making sense?
Yeah.
Let me analyze what happens to my slope function on the right of minus 1. So let me take another point, say 0. So when I take 0 and I put 0 here, this becomes plus 1 and this becomes minus 1. So 0 minus 1, negative. So my slope is negative this side. Are we clear?
Yeah.
In 2 minutes things will start falling in place, don't worry. Again I take a point which is on the left of plus 1. Let me take 0 again. So when I take 0, I know that when I take 0, let me take another point like maybe, so that things become clearer. Let me take a point like half. So if I put half here, this half plus 1 would be positive this side, and half minus 1 would be negative this side. Plus into minus is negative. So left of plus 1, my slope is negative, and if I take any random point which is on the right of plus 1, let me take it like 3. So 3 plus 1 is 4, 3 this would be positive. Avantika, are we clear till here? Now let us try to interpret what is happening. So at this point, minus 1, my slope on the left is positive. The slope is positive. It reaches 0 and then it turns negative. Is it making sense? Avantika, is it making sense?
Yeah.
Again, if I look at plus 1, on the left of plus 1, the slope is negative, comes to 0 and then takes a positive turn. Is it making sense?
Yeah.
So slope, if it changes from positive to 0 to negative, this point would be local maxima. Is it making sense?
Yeah.
If slope changes from negative to 0 to positive, this would be local minima. Is it making sense?
Yeah.
So what I have analyzed is that for this function Avantika, the at point minus 1, basically point minus 1 would be the point of local maxima, and point plus 1 would be point of local minima. Is it making sense?
Yeah.
Okay. Now let us come back to physics and try to understand what does this imply from a point of physics. What it implies from a point of physics is that if we are given a function like this, that there is a particle, like we saw before, there is a particle which moves as per, or let me take example from the book also only, so that things become easier for you. So I'll show you that example, but what I want to show you now is that how does it make our life in physics easier. So I will send you the page scan. So for example, at page number 406, the question is that there is a particle which moves in a straight line. The displacement of the particle is given by t cube minus 12t square. Actually, what I'll do tomorrow is I'll take few examples from your NEET paper, so that you get confident that questions are asked on this topic from NEET also. Otherwise, you might be thinking, "Arey sir, pata nahi kya karte ja rahe hain." So for example, this question, what they are asking is that what is the velocity at t is equal to 2. This is the first question which is being asked. The second question which is asked is find acceleration at t is equal to 4 seconds. The third question which is being asked is find the value of t when the particle is instantaneously at rest. Have you understood?
Yeah.
Now, this is what I want to arrive at, that how do we answer this? Particle is instantaneously at rest. Have you understood this question?
Yeah.
Now, with the background that we have, we understand that the particle would be instantaneously at rest, where the velocity function would be 0. Have you understood?
Yeah.
So, what we need to do is we need to find the velocity function. The velocity function would be 3t square minus 24t plus 45. The acceleration function would be 6t minus 24. So I can put this value of 2 here and I can find the velocity. I can put the value of t is equal to 4 here and I can find the acceleration. Am I making sense?
Yeah.
And if I want to find the time at which the particle is instantaneously at rest, I need to put my velocity function as 0. Am I making sense?
Yeah.
So basically what I need to do is I need to put this 3t square minus 24t plus 45 is equal to 0. Is it clear?
Yeah.
And because it's a solved example, so I'll tell you the one second. Yeah, the at time t is equal to 3 seconds. I will send you the solved example. At time is equal to 3 second and 5 second, the particle is instantaneously at rest. Am I making sense?
Yes, sir.
Okay. Now D part, what they are asking in the question is, I will share the question with you. D, what they are asking is distance of the particle from x from the origin when t is equal to 7. Now what they are asking is that what is the distance of the particle at t is equal to 7 second. Now this part is simple because I am given a displacement function. I am given this displacement function. I put the time t is equal to 7 second and I can find the displacement of the particle from its origin. Are we clear till here?
Yeah.
Okay. And the last what they are asking is, the last thing that they are asking is what is the total distance the particle has traveled. I'll show you the question one second. So this is the question that we are discussing. This is the question that we are discussing. So we can calculate the velocity, we can calculate the acceleration, we can calculate where exactly the particle was at rest. We know that at rest the instantaneous velocity would be 0. Are we clear?
Yeah.
And find the total distance of the particle from origin when t is equal to 7. Are we clear? Now what he is saying is find the total distance traveled by the particle during the first 7 seconds. He is asking us the total distance. Now if you look at this part, so at the particle was instantaneously at rest at 2 points where the velocity was 0. This is what I told you, that at 2 is equal to 3 second and t is equal to 3 second and t is equal to 5 second. Now if you look here, that the displacement function is Avantika, I'll restart the meeting. Just give me a second. Yeah, just give me a second. Before I start writing, I'll restart. 1 second. So basically when we look at this part, E, find the total distance traveled by the particle during the first 7 seconds. Now this is where our knowledge of maxima, minima and the positive negative sign will start making sense to us, and we will be able to understand how these things are helping us. So this is my displacement function. Avantika, are we clear?
Yes, sir. Sorry, I was on.
So yeah, so this is my velocity function. This is the first differential. So this is how it will look like, and my velocity is 0 at 2 points. One is at 3 and the other point is 5. Are we clear?
Yeah.
So at 3 and 5, I basically know that my particle will come to rest instantaneously. Are we clear about this? Avantika, are we clear about this?
Yeah.
So because what we need to understand is because my velocity function has become 0. So it is like saying you take a ball, you throw the ball up. At its highest point, the velocity would be 0. And if we interpret it further, what we will see is, let us assume that up is positive. So velocity while going up is positive. From positive, it becomes 0 and then it becomes negative. Have you understood?
Yeah.
So in this case also, something has happened to the particle that it has changed direction. It might have changed direction. This is what we suspect. And to further investigate that what exactly would have happened, what we take is we take this point t is equal to 3 second. On the left side of t is equal to 3 second. Wait. On the left side of t is equal to 3 second, what we see is that left side of t is equal to 3 second. Let me take a point like 2 second. At 2 second, my velocity function 2 minus 3, negative, 2 minus 5, negative, negative into negative is positive. So my velocity function is positive. Avantika, is it clear? Avantika, is it making sense?
Yeah.
On the right side of t is equal to 3 second, I take a random point like 4. If I put 4 here, 4 minus 3 is positive, 4 minus 5 is negative. So positive into negative is negative. So the velocity function is a negative on the right side of 3 second. Is it making sense?
Yeah.
So what we can understand with our base of maxima minima is that around t is equal to 3 seconds, the velocity changes from positive velocity to negative velocity. Is it making sense?
Yeah.
This is the same like saying my stone has reached the highest point and from there it is coming down because the velocity is changing from positive to negative. Are we clear?
Yeah.
Again, using the similar knowledge that we have gained from maxima minima, if I start analyzing my particle at t is equal to 5 seconds, on the left side velocity is negative, on the right side my velocity is positive. So again the particle has changed direction. Are we clear?
Yeah.
It is like you were going on a road, you forgot something, you came back and then you realized nahi wo to hai mere paas, and then you went back on the road. Are we clear?
Yeah.
Okay. Now let us try to see how does this look like. And I am, again and again I am insisting that this is something that you will find in competitions. So don't think that फालतू की बात है. Maybe tomorrow I'll discuss 4-5 neat questions with you, in which this differentiation maxima minima would be used. Are we clear?
Yeah.
Okay. So this is my particle at t is equal to 3. At t is equal to 0 second, it starts moving. Let us assume this side. Now, at 3 second, my velocity is 0. So, how I interpreted this is that it was going this side, and then something happened. It changed its velocity. It became negative. Are we clear till here?
Yeah.
So, at 3 second, the total distance that the particle would have covered is 54 meter. How did I find this? I used t is equal to 3 second. I used this function x is t, and I found the value of my displacement at t is equal to 3 second, and I found this to be 54 meter. Are we clear?
Yeah.
So till 3 second, my particle had come to 54 meter mark. Now, what I want to see is that again, what I know is that at 5 second, it changed its direction again. So it was going in this negative direction. So basically, you were coming back to your home to pick up the thing that you have left. But again, you realize that you already have that in your car and you turned in the positive direction again. Are we clear till here?
Yeah.
So now let us examine what is happening at, see, this is 3 second. 3 plus 2 second is 5 seconds. So this is basically my 5 second. At 5 second mark, if I see at 5 second mark, you are 50 meter away from your home. Are we clear?
Yeah.
You are closer to your home. Are we clear?
Yeah.
And then the question asks, let us look at the question again, what the question is asking. The question asks that the total distance traveled by the particle during the first 7 seconds. So the question is asking us about the first 7 seconds. This is 3 seconds. This is a total of 3 seconds. This is a total of 3 seconds. This mark is a total of 3 plus 2, 5 seconds. And after 7 seconds, the particle is at 70 meter mark. Are we clear?
Yeah.
So the particle at 7 seconds would be somewhere here, and it would be at 70 meter from the home. Are we clear till here?
Yeah.
Now, see, the point that I'm trying to make is that unless and until you are able to read the graphs, the slope of the graphs, how will you be able to make out whether the velocity is positive, negative, and where the body changes its velocity from positive to negative, from negative to positive again? Is it making sense?
Yeah.
Now, I understand that the things are getting a bit complicated, but you covered 54 meter till here. Have you understood?
Yeah.
Then at this time you were 50 meter from your home. So basically you would have turned 4 meter back. Is it making sense?
Yeah.
So this was 4, and from this 50 meter to this 70 meter, you have covered 20 meters. Are we clear?
Yeah.
So therefore, the total distance covered is 78 meter, while the total displacement is only 70 meter. Are we clear?
Yeah.
Now there's another thing that I want to tell you. Of course, this is confusing the things far more than is required. If you look at the acceleration function, What the acceleration function is saying is that the acceleration increases with time. As time goes on, the acceleration is increasing. It is not constant. Avantika, is it making sense?
Yeah.
And that is what you will see in the motion of the particle. If you see from this point to this point, while going back, it was 2 seconds, but in 2 seconds it had only covered from 54 to 4. It had only covered 4 meter. But when it reversed direction, because it is an accelerating particle, in from 5 second to 7 second, in 2 second it is able to cover 20 meters. Am I making sense or not?
Yeah.
Because it is a particle whose acceleration is not constant. The acceleration is also increasing. Are we clear?
Yeah.
So, see, this is what I wanted to discuss. This concept of maxima minima. I'll send you these solved example. Just look at these solved examples, because we are not much interested in we are not very much interested in the solving extra tough questions which the maths people usually do, because the non-medical students would be required to solve these extra tough maxima minima questions. You are not required, but at least we should have a fair amount of understanding how these questions are done. Are we clear?
Yeah.
If you want, you can do one of the easier questions which won't require much of differentiation. This is a question that you can do if you want. Are we clear?
Yeah.
And as a homework, finally what you are driving at is that how does all this differentiation help you in solving physics questions. This is the lecture that you will have to see. Can you see this lecture? I will send you the link.
Okay.
So, application of differentiation, find position, velocity, acceleration using calculus. Are we clear?
Yeah.
And again, as I told you, when we will be doing the direct application of this maxima minima would come when we will be doing simple harmonic motion. So, there will be a block which will be attached to a spring. You give a force to the block, say left or right side, then the block starts moving in like this simple harmonic motion. When we do this simple harmonic motion, again these maxima minima differentiation basics we will be using. So there will be a displacement function, then we'll be able to draw a velocity function out of that. We'll be able to draw a acceleration function out of that, and using our concepts of maxima minima, we'll be able to see where the velocity is 0. So basically what I'm trying to tell you is that at the extreme position, you will understand when the block is at the extreme position, the velocity is 0. Have you understood? Because the block has to come back. Is it making sense? Avantika,
Yeah.
am I audible? So again, when the block is the blocks comes here, again the velocity will have to be 0 because it has to change direction again. And these things, see, what we know by intuition, these things would be visible in the equations also. Am I making sense?
Yeah.
See, you just need to have a flavor of the maxima minima. This lecture would be easier for you. This lecture would be easier for you because in this lecture, maxima minima are not used. When we are doing simple harmonic motion, we will come to this lecture again. And then I'll discuss with you that how this maxima minima basics are affecting you. Are we clear?
Yeah.
So tomorrow's agenda is few questions from NEET which require differentiation, and then if time permits we'll start integration. Are we clear? Miss Avantika, are we clear?
Yeah.
Okay, so I'm stopping the meeting. Yeah.
No.